Hello, everyone. My name is Marcy Samuelson, and I am Marketing Manager for the Developer Initiative here at Oracle. Thank you for attending today's Tech Classroom, Monitoring Modern Container Infrastructure with Datadog. Before we get started, I would like to review a few housekeeping items. The webcast console you are looking at can be completely customized. You can resize or move any of the windows that you have open. At the bottom of your audience console, there are multiple application widgets you can use. If you have any questions during the workshop, you can enter your question in the Q&A area and submit your question. We have a number of Oracle experts on the call that are ready to help you. If you experience audio or screen issues, please make sure the audio is turned on in the media widget or press F5 to refresh your screen. This webcast will be made available on demand after this live event. You will be able to access from the same link as the link you used to access this live event. Again, thank you for joining the Tech Classroom, Monitoring Modern Container Infrastructure with Datadog. This webcast will be presented by Technical Evangelist from Datadog, Ara Pulido, and Principal Product Manager from Oracle, Gilson Malo. At this point, I will turn it over to Gilson.
Thank you, Marcy. So this is Oracle's Safe Harbor, and I'll give you guys a few seconds to read it. Before we jump into Datadog content, let me give you an overview of Oracle Cloud Native Services. And let's start with Oracle Kubernetes. Why Oracle Kubernetes? Oracle Infrastructure Container Engine for Kubernetes, also known as OKE, is a fully managed, scalable, and highly available service that you can use to deploy your containerized applications to the cloud. For information, OKE is open and enterprise-grade with no vendor lock-in, since Oracle Kubernetes is based on upstream version for the Cloud Native Computing Foundation, or CNCF. When your development team wants to reliably deploy and manage cloud-native applications. So Oracle's cloud-native services leverage highly performant next-generation Oracle Cloud Infrastructure, also known as OCI. So these services can be categorized into application, development plus operations, and observability plus messaging. See here, we provide several cloud-native services that, combined with OKE, will give you a robust and scalable cloud-native services environment. So for example, we have streaming services, which is fully Kafka compatible, logging services compatible with Fluentd, native monitoring services, notifications, events, API gateway. We also provide infrastructure as a code to our users, which is basically our Terraform option in the cloud that allows you to run your Terraform stack directly through the UI or command line, along with other services like functions, for example. So you have all of these services available to you to use along with your Kubernetes deployment in the cloud. Okay, about this slide. Oracle is the only major cloud provider to deliver and support a unified cloud-native solution across managed cloud services and on-premises software, supporting seamless bidirectional portability of cloud-native applications built anywhere on the framework. So, since the framework is based on open cloud-native computing foundation certified and conforming with standards, it will not lock you in. That means that applications built on the Oracle Cloud Native framework are portable to any Kubernetes conformant environment, any cloud or infrastructure. So in addition to that, for example, applications running on WebLogic on premises can be easily containerized or put in containers and then lifted and shifted into Oracle Container Engine for Kubernetes without having to re-architect or rewrite any code. This makes the migration to public cloud very easy. And along with that, Terraform configurations can be reused across Oracle cloud environments and modified for using other cloud environments as well. As you can see here on the left side, Oracle has leadership roles across different open source communities like Linux, MySQL, Kubernetes, Linux Foundation, and others. And bringing open source software to Oracle Cloud Infrastructure, it's fully supported And we also incentivize that for customers to bring all their open source tools that they have. Along with that, we have a very good relationship with HashiCorp. So HashiCorp Terraform provider is fully compatible with Oracle Cloud. Kafka streaming, like I mentioned before. Fluentd logging. We also provide Chefy and Ansible modules for our users. And you can also use Maven to build using the developer cloud service, for example. So continuing the details from the previous slide, as you can see here, Oracle is a platinum member of the Cloud Native Computing Foundation, and Oracle is also a member of the Open Container Initiative. Oracle's second generation cloud infrastructure, again known as OCI, gives you the capability of bare metal shapes, virtual machines. We also provide containerized compute, GPUs, HPC shapes for all the performance-intensive workloads you might have on your side for AI or machine learning. And we also provide a variety of cloud storage options as well, like block, object storage, file, and archive, that can all be used with your containers in the cloud as well. OCI offers also a fantastic array of services for developers building modern applications. You have the choice of any programming language and framework, like Java, JavaScript, Node, Python, Ruby. So we're not restricting our users to specific programming languages. You can bring your own programming language to our cloud and use along with our containers. You can use any developer and DevOps tools. And we also provide a set of free tools that you can use in our cloud. We also offer low-code platforms such as Visual Builder to make it very simple for developers to create apps with little to no programming. Along with that, we also offer an integrated data platform for enterprise. That includes our flagship autonomous database, but we also offer the choice of database like MySQL. And recently, we started offering even Microsoft SQL Server in the cloud. And we also provide a service, Apache Spark service called Dataflow and big data workloads for users, for Hadoop users willing to use those services in our cloud. Finally, we provide a number of services to help you manage and secure your applications in the cloud. Awesome. Let's talk now about OKE, our container engine for Kubernetes, and OCR, Oracle Cloud Infrastructure Registry. So OKE is a developer-friendly and enterprise-ready managed service that runs high-available Kubernetes cluster with control, security, and the performance of the Oracle Cloud Infrastructure. We shared a few details in the previous slides. It's completely compatible with the CNCF ecosystem, and OKE also supports Helm for easy deployment of your own Kubernetes apps in the cloud. About Cloud Infrastructure Registry, or OCR, is a high-available container registry fully compatible with Docker V2 that enables users to easily store and share their container images. So you can use, for example, pull and push images with your Docker CLI, or you can also pull images directly into the Oracle Container Engine for Kubernetes deployment, for example. So the gray shade area on our left side designates the functions that the Oracle manages for our users, including an integrated registry and image storage and container engine or managed Kubernetes. Oracle also manages the etcd and master nodes of the Kubernetes instance in a high available environment for users. So for example, upgrades to new versions of Kubernetes will also be supported to the dashboard. So you, the user, is responsible for deciding when to upgrade to the next Kubernetes version when we make that available to our users. On your right side, customers will manage those resources that are basically used for your worker nodes. So storage, compute, network are all the resources that the user will be responsible for. So let's talk now about pricing and packaging. The good news here is that users do not pay for any of the Oracle managed container infrastructure. The gray area on your left side. This is the control plane that enables you to configure those services, maintain operations, versions, availability, etc. The users pay regular fees for compute, storage, and network used in the data plane, or the blue area on the right side, where your applications will run and your data will be stored. So we spoke about some other services, OKE, OCR, some pricing options, but what about the integration with the Oracle Cloud Services like Autonomous Database, object storage, streaming, logging? Well, the good news is that we do provide a new service to our users called Service Broker for Kubernetes, which is basically an implementation of the Open Service Broker API that you can use in a Kubernetes cluster to provision and bind to OCI services that your application depends on. So these integrations include, for example, some OCI key services like autonomous transactioning, processing, database, the autonomous data warehouse, the streaming service, and object storage. So the main key benefit of using the service broker is basically reducing the complexity in your app deployment and making it easier for you to integrate your container services with other native Oracle Cloud services. Now let's talk about persistence and containers. As you might know, applications can be categorized in either stateless or stateful apps. So stateless apps do not require persistence, while stateful apps do require persistence. So that's why it's important for us to provide that capability in the cloud as well. So for your stateful apps that require some persistence or to avoid losing data, you have some additional benefits, which include, for example, integrating your containers with block storage or our NFS as a service called file storage service, and also object storage. And for your stateful app that require a database, like we mentioned in the previous slide, you can also fully utilize the database options that we have available today, like Oracle Database, Autonomous Database, Virtual Machine or bare metal shapes, along with Exadata Cloud Service as well. Okay, now that you understand a little bit better about OKE, OCR, and all the other cloud-native services that Oracle provides, let's talk a little bit more about Datadog and how you can use Datadog services with OKE.
Okay, thanks, Gilson. My name is Ara Pulido. I'm a technical evangelist at Datadog. This is going to be the agenda for today. So we are going to give a little bit of overview of Datadog, what it is and what it can do for you. Then we are going to do a demo of how to deploy the Datadog agent on OKE. And we are going to see how to start gathering metrics, logs, events, service checks, etc. Then we are going to talk about a feature in Datadog specifically for Kubernetes called auto discovery. And finally, we are going to be talking about the cluster agent and cluster checks. Okay, let's start doing a little bit of overview of what is Datadog. So Datadog is a SaaS monitoring and analytics service that helps companies improve observability of their infrastructure and their applications. So one of the key differences of Datadog is that it ships with more than 350 integrations. So when you want to start monitoring your infrastructure, instead of having to start thinking about what metrics should I gather, etc., you can use one of those integrations to get you started. So for example, if you're using Circle CI for your CI/CD, or you're using Console or Docker, all of these, they come with default integrations. And I'm going to give an overview of Datadog that explains a little bit how this works. Obviously, one of the integrations that we have is Kubernetes, and that's the one that we are going to be talking about more. So let's move to a demo environment to give a little bit of overview of Datadog.
Okay, so this is the interface of Datadog. So we are going to be showing some of the most important features of Datadog in this demo environment, and then we are going to go and explain how to set it up for our OKE cluster. So one of the first things that we mentioned about Datadog is that it has more than 350 integrations, and this is a very easy way to get you started with Datadog and start monitoring your infrastructure. So you can see here an example of all the integrations that are available. And one of the good things about the integrations is that most of them come with a default dashboard. So for example, this is the Kubernetes one. So when you install the Kubernetes integration that we are going to be talking about, you will get this dashboard by default. And it will give you enough information about your cluster. So for example, how many of your kubelets are up, if they're responding, CPU utilization of each of your nodes, the number of pods, the number of replica sheds, etc. This is a very good way to get you started. At some point, obviously, you will need to build your own dashboards to gather the information that you're mostly interested in. But this is a very good way to get you started very easily. Another visualization that we have at Datadog that is super useful is the host map. It allows you to show very quickly the host in your infrastructure and also the container. So this is the hosts, so basically VMs or bare metal where we have the agent, but we can also get the list of containers that are on our infrastructure. And we can group them for any tags that we have. For example, one of the tags that we have by default is the deployment. We can see here all the deployments are in our cluster, and all these containers are color-coded by a metric that we select here. So in this case it's I/O writes, but let's, for example, select user CPU. And quickly we can see that product recommendation deployment has some containers that are very CPU intense. So something probably that we want to have a look and investigate. Datadog is not only about monitoring your infrastructure, but also monitoring and tracing your applications. So this is another visualization that Datadog has, which is the service map. This is a map of the dependencies between all the services in your infrastructure that are sending tracing data. And also they are color-coded by alerts. So for example, we can see here that email API PI has some error. So we can maybe select the service overview. The service overview is a dashboard for every service that it's sending tracing information with all the basic information that we would be interested in. So for example, here we have the 4 alerts that we have set up for this service. One of them is firing, and we can check here which one is firing and investigate a little bit more. We also have the total number of requests per second, the errors per second, and also the latency. We can also have the P90, P95, and P99 latency of the service. So this is a very high-level overview of your service that you can access very quickly through the service list of the service map. Also, you can get a list of containers, which in our case is probably useful. You can see all the different containers that are in your infrastructure, and for each of them, for example, this is running in Kubernetes. For each of them, you can get the list of process that it's running. Another cool feature is the time boards. Time boards allow you to check any metric on the same time frame in a very visual way, and every metric here can have 15 months of retention, so you can go back to 15 months from now with a granularity of 15 seconds. So you can basically select, for example, the past month, and you can get all that data. Another cool thing to mention is that all the tags that are coming from the metrics are not only for the metrics. The tags are shared between metrics, traces, and logs. So you can basically check very quickly the logs for this point on time, just clicking here and say view related logs. And you can see all the metrics all the logs, that are related. One of the things that is important to mention about the logging solution in Datadog is that all the parsing happens on ingestion. So once you see the logs here, they're already parsed. You can, if you want to get a specific one or search by a specific one, you can do so easily by clicking on this filter. So if I want only to get errors from the email API pie, doing a couple of clicks, I have them here, and I can check, for example, that I was getting a traceback here and investigate. The last thing I want to mention on this high-level view is Watchdog. Watchdog is a set of events that outliers that get discovered using artificial intelligence. It's completely, you don't have to set up anything manual, you don't have to set up any thresholds. Basically what it's going to do for any metric in the system is going to gather all the data of what happens usually, and when something gets basically any anomaly that it finds, it's going to check it here. So it's a very easy way to find errors that you didn't even know that were occurring. And that's it. Let's move on to see how we set it up for our OKE cluster.
Okay, so now that we've seen an overview of Datadog, let's see how we can use Datadog and the Datadog agent to start getting those metrics from an OKE cluster. So we are going to explain how to deploy a Datadog agent in an OKE environment. It's going to be all demo-based, so you will see a real OKE cluster while we're doing this, and then we were going to see how you start getting metrics, logs, events, service checks, etc. So just to give you an overview, this is the OKE cluster that we are going to use. So you can see it's a real Kubernetes cluster with 3 nodes, and this is the cluster that we are going to be using throughout the demo. So the Datadog agent deploys as a daemon set in our Kubernetes cluster. So that means that for every single node that is part of our cluster is going to have a pod for the Datadog agent. And that pod is going to be talking with the kubelet and also with the Kubernetes API server. So once we deploy the agent, we start gathering metrics. Where do those metrics come from? So they come from different places. So for example, they come from our system metrics. So they start gathering metrics about our host, our nodes, about CPU usage, memory, etc. Then it will also gather metrics from the kubelet. So the kubelet is the process that runs your containers in Kubernetes. And every node is going to have a kubelet process. So the kubelet process is going to know a lot about what pods are running in that node, how much memory they're using, etc. So all that information is going to be sent to Datadog. And finally, it's going to gather metrics from kubestate metrics. And I'm going to explain a little bit more what it is. So kubestate metrics is an external service that is part of the Kubernetes project that basically what it does is gathering metrics from the Kubernetes API. So the Kubernetes API, you can get information about replica sets, daemon sets, deployments. All the information can be gathered from the Kubernetes API. So kubestate metrics, what it does is exactly that. It's gathering all the information, and in this case, it will send it to Datadog. So now that we know a little bit more about the Datadog agent and what it does, I'm going to switch to the demo environment, and we are going to see how we have deployed the Datadog agent in our OKE cluster and how we start seeing all these metrics and logs there.
Okay, the first thing we are going to see our cluster. So let's check that we are on the right one. So if we do kubectl get nodes, we will see that we have our cluster that has 3 nodes, as we said. And the first thing that we would need to do in order to start gathering metrics and logs from Datadog would be to set up the agent. As we said, the agent is deployed as a daemon set, which means that we have a one instance, one pod per node. And there are things, this is comes in the documentation, how to set it up. There are things that I want to highlight. So the first thing what we need to do, obviously, is we have to set up our API key to make sure that we have sending the data to the right organization in Datadog. The other thing I want to mention is that if you want to enable logs, you will need to set up these 2 environmental variables as well. The first one, DD logs enable, basically said, please send the logs to Datadog. And the second one says that anything that the containers in our cluster is going to emit, please collect it. So basically anything that you would get by running kubectl logs will be sent to Datadog. And the third thing I want to mention is this one, Kubernetes pod labels as tag. If you're a Kubernetes user, you would know that any object in Kubernetes can be labeled, and actually it's a good practice to label your nodes, your pods, your deployments, to make sure that to organize your deployments basically. So if we check per logs, you can see that there's also labels here, and because you already do that effort in Kubernetes, it would be good to reuse those as tags for our metrics and our logs. And this is exactly what this option does. So basically what it's saying is, for any label that I find, please transform it into a tag that it's the same name with a prefix of kube. In this case, we are collecting any label, but you can, instead of using a star here, you can just create a list of the labels that you're interested to transform into tags. The second thing I want to mention is the kubestate metrics. So as I said, this is an external service, so you have to deploy it. This is the default deployment that comes in their documentation, so nothing a lot to see here. The only thing is in this case, we are using one replica only, and we have the kubestate metrics default image. So these 2 things, let's have a look how they look in our cluster. It's already deployed. So let's say that I want to see the Datadog agent. Let's do this white so we see the node that they're deployed to. So we have here 3 pods of the Datadog agent, each of those running in a specific node. Let's see the kubestate metrics pod. We can see that it's in a different. So it's here running on the kube system namespace. It's already running, so we're already collecting that data. So let's have a look to our organization in Datadog. This is the new org. So as we can see, we have on a host map that we showed before, we have 3 nodes. Because we have the integration, the Kubernetes integration, we have a default dashboard, and we have it here. In this case, instead of 68 kubelets that we saw before, we have 3. The 3 of them are responding, the number of containers, that we have running and stopped, the number of pods, etc., etc. So all the data that we were seeing before. So where is this metrics coming from? So if I want to know, once I run the daemon set for the Datadog agent, if I want to know what metrics are available for me, the best way to do that is through the metrics summary here. So on the metrics summary, you can see all the metrics that are being sent to Datadog. So for the ones on the kubelet integration, the Kubernetes integration, everything starts with Kubernetes dot. So you can check all of this. For example, if you want to have the number of pods running, you click here, and also you have the type of metric, in this case a gauge, the integration, where it comes from, and the description. So it's a very good way to understand where those are coming from. And again, this is all the different tags that are collecting. So if I want to see the number of running pods in this application that I have deployed, I can just click here, and it would go directly to the metric explorer, and it will show me the number of pods that are running. So going back to same thing, if I want to check the logs, I'm already seeing the logs here. So if I can click, for example, on this particular metric, and I can see the related logs corresponding to that particular node. I can expand that and see it directly on the log explorer. So I can make sure that I can be able to filter by service, by type, if I want to see only the errors, or if I want to see everything, I can click here. And another easy correlation that we can find when we are investigating an outage is checking the events. So the Events Explorer basically checks anything that happened that it's considered an event. Like, for example, we deployed a new version of our application, or a node became unavailable, or I scaled horizontally one of my applications. All those events will be registered here. So when you're trying to understand what not just happened, it could be a good way to start with. Okay, so let's go back to the slides. I'm going to be explaining auto discovery now.
Okay, let's talk about now auto discovery, what it is and what can help you with. So as we said, Datadog has more than 350 integrations, and you maybe wonder how you can enable those. So how to enable, if you're running an Elastic cluster, how to enable the Elastic one, etc. So let's talk about it. So when you are in a usual VM environment, and for example, you are running Redis in a VM, and you want to enable the integration for Redis, it's easy doing that using a configuration file, because you know the IP of Redis and the port where it's listening to. In this case, in this example, we set it up to localhost, because we're saying here that Redis is running in the same host as the Datadog agent, but you can put any IP. That's for an usual VM environment. But what happens when we move to Kubernetes? So we know that pods are ephemeral and IPs gets created and deleted. So you don't know exactly, for example, in the case of Redis, the IP. You may know the IP of the service, of the Kubernetes service, but you don't know that up front, and obviously that can change. So how we can say, okay, I want to enable the Redis integration for my Kubernetes cluster. This is where auto discovery comes in. So there are two ways to do that. So for some integrations, like for example the Redis one, there is an autoconf file that specifies what pod data the Datadog agent is going to look for to enable or disable some integration. So in this case, for any pod that uses the Redis image, the Docker Redis image, it's going, it's going to enable automatically that Redis integration. But what happens for integrations that don't have an autoconf because it requires some configuration, or maybe the image name is different, it's not called Redis if you're using Redis because you have repackaged the Docker image with your specific infrastructure. So what in these cases? So what we can do is using Kubernetes annotations to specify what checks we want to enable. So we are going to switch back to the demo environment, and we are going to see examples of both. So we are going to see first the Redis autoconf one, and then we are going to see the Mongo one using Kubernetes annotations.
Okay, so let's have a look to our agent status. So let's quickly check our pods. And then we are going to check one of the agent status of this pod, for example. This is a command on the Datadog agent to see all what's happening on that agent. And one of the things that we can see is that the different checks that are running, and we can see that Redis is not there. If we see a number of pods, we don't have any Redis pods, so it makes sense. So we are going to basically apply now a Redis deployment, very basic, with the default image called Redis. Let's see what happens when we do that. We can see that now we have a Redis deployment called RedisDB with one pod. And if we run again the agent status, thanks to auto discovery, the agent is going to start activating the Redis check and is going to start sending Redis specific metrics and checks to Datadog. Again, as any integration, it has its own default dashboard. So if we go to our dashboard list, now we have one for Redis. This is by default. We didn't have to set up anything, just install the metric, the RedisDB container, and installing the integration in our organization. And you can see that we can start seeing metrics specific to Redis, like for example the commands per second, cache hit rates, the latency, etc., etc. But what happens when there is no an autoconf specific for our image? This happens, for example, in Mongo, as we saw on the slides. So because we don't have an autoconf for Mongo, what we can do is we have this Mongo deployment. Let's check quickly on this that we are not running the Mongo. Currently, we are not running this alphabetical, so memory to network. We are not running the Mongo check yet. And we are going to deploy this Mongo deployment with just one replica. It's just an example. And basically we are saying, okay, for this particular deployment, I want to run the Mongo check. I'm going to tell it how to connect to the admin database where I can get all the metrics. And I'm also going to tell it to tag it as source and service Mongo and MongoDB for the logs. So let's do that. Let's see if our pod is running. It's running here. These are one replica of MongoDB. And if we run again the agent status command, hopefully we will see that it's not running yet. Okay, you can see that now it's running, but it's failing. Why it's failing? Because we provided an authentication that we haven't actually created yet. We have to do that. So how we do this? We get the pod name to exec to the MongoDB database, CLI. Let's do that interactive as well. We are going to switch to the admin database and we are going to create a user. I'm going to copy and paste the data. So I'm going to create a Datadog user that can read on the admin database. So if I quit here, and if I run again agent status, and now it's running okay. So this is the Mongo check, it's running, it's enabled, and same thing, we will have a default dashboard that we can use thanks to the integration that we can use to start checking our metrics from our Mongo.
Okay, after auto discovery, we are going to finish by talking a little bit about the cluster agent and the cluster checks. So if we go back to this diagram of the Datadog agent, we can see that every node agent is talking to its kubelet, which makes sense, but it's also talking to the API server. When you scale a lot a cluster and you start having a lot of nodes, all of them are going to be talking to the API server, and that becomes a little bit of a bottleneck. So what we do in that case? So to avoid that problem, we can also deploy the Datadog cluster agent. The Datadog cluster agent, basically, it's a proxy between every Datadog agent node and the API server. So instead of the cluster agent is going to collect all the information about the API server, and every node agent can talk to the cluster agent to gather that information. Another feature that comes with the cluster agent is actually cluster checks. What does it mean? So right now, everything that we've seen was about gathering metrics about our pods, and that was good. Obviously, when you're running Kubernetes for many services, you're going to scale horizontally. So, for example, your Redis database may have several pods, or your Nginx pod have several pods. So in those cases, usually what you do is to create, in any case, you create a service, a Kubernetes service, that is going to load balance that traffic between all the pods that are part of that service. So how can you get cluster-wide metrics? So for example, if you don't want to know the response time for a specific Nginx pod, you want to have it for a specific service, so globally for all the pods that are part of Nginx. So what we are going to see now is an example of how to do that using cluster check.
Okay, let's have a look to our deployment of the cluster agent. So in this case, it's not demonstrated anymore because we just need one. This is going to act, as we said, as a proxy between the node agents and the Kubernetes API. And yeah, we have to populate some of options like the API key. Everything is in our documentation. So let's have a look how it looks like. So if we do kubectl get pods, we see that we have here the cluster agent running correctly. And actually, if we run the agent status at the very bottom of the agent status on any node, it will tell you whether it's being able to connect to the cluster agent successfully. So in this case, everything is working correctly. So let's see how we would enable one of these cluster checks. So we have an Nginx deployment with 3 replicas. And basically, we are saying that for any part of this deployment, we are going to be running the Nginx check. Let's have a look to our pods. We have the 3 Nginx replicas running here. And actually, if we go to our dashboards, we will see that we have an integration for Nginx enabled. And we can see all the metrics that we are gathering for our Nginx pods. With our requests per second, with requests read, writing, by host, etc. So what happens if we want to make sure that we get HTTP response times from a service rather than each of the pods? Obviously, we can do all this math afterwards in Datadog, but maybe we can get that number directly from the cluster. So how we do that? So here we have the service that we are going to deploy. There is a check, an integration in Datadog called HTTP, that one of the things that gathers is the response time. So in this case, we can say, okay, I want to enable this check for this particular service cluster-wide. So all the maths between the different pods is going to be done at a cluster level. And we are going to get that data directly from our cluster. So let's apply that configuration. Let's see that exists correctly. We have it here, the Nginx service. And now if we run the cluster checks, so basically what we are going to do is a kubectl get pods. Let's get the pod name for the cluster agent. And we are going to do something similar, but instead of running the status, we are going to run cluster checks, which is the command to check with cluster checks we are running. As you can see, we have enabled, same with auto discovery, this HTTP check for this particular service. So instead of having this check for a container or a pod, this is cluster-wide for the service. If we go to the metrics explorer, we can check the HTTP network HTTP response time, which is the metric that we will be gathering for all the instances of Nginx. As you can see, this metric just started to gather data because we just enabled that cluster check.
Okay, thanks very much. This is all I had. I hope you enjoy it and you find it useful and want to start improving observability of your OKE clusters. So if you have any questions now, I'm happy to answer them.
Thank you, Ara and Gilson. I just wanted to take a look at the chat because we have a few questions there. I'll go ahead and ask them. You have mentioned that you have a default 15-month retention for metrics. What about logs?
Good question. So log retention is basically decided on contract. So when you're negotiating your contract with Datadog, you can decide how it's up to you to decide how long you want to retain your logs. But one of the things that is worth mentioning about log retention at Datadog is the new feature logs without limits. And basically, when people get a log solution, they're very worried to control the cost. So what people usually do is to filter the logs on their side, on server side. So basically deciding upfront what logs they want to index in their solution and what not. But the problem with that is that you may be losing good information, important information that you didn't even know you will need in the case of an outage, for example. So here is where it comes logs without limits. So with Datadog, basically you can send all the logs as much as you can, and then on our side, on Datadog side, you can decide dynamically which ones you want to index. And I mean dynamically. For example, if you're sending every log, including debug logging, but you don't want to index them, and therefore you don't get charged for them. But then during an outage, you may want to re-index those, and you can basically start indexing those straight away. Or also you can use our livetail, which is a stream of all the logs that go to Datadog live. Even the ones that you are not going to index will appear there. So during an outage can be very, very helpful. Also, for all the logs that you get into Datadog, you can send them at no charge to your cloud storage, for example, to your long-term storage. And that way you know that you have those logs, even if they are not indexed at that time, and then get back to them if you ever need them. Move them back to Datadog and index them. So it's a good way to control the cost at the same time you're making sure that in the case of an outage or you're debugging an issue, you're going to have all the information that you need.
Great. I think there's one in here for Gilson. Does OKE support scaling Kubernetes to a few thousand servers?
Yes, today OKE has a limit of 1,000 nodes per OKE cluster, but that's a soft limit. Customers can have multiple clusters, for example, and if they need to increase the limit, they just need to work with our support team to increase the number for them.
Okay. And there's another one here. Does OKE support the multi-cloud container deployments?
Yeah, that's a great question. You saw some of the details during the presentation, but basically, OKE conforms to standard Kubernetes deployments, practices, and methods. So customers can utilize any open source tools that they like with OKE in general.
Okay. And I think this one's for Ara. Aside from the main Kubernetes integration, do you have any other integrations for components that you usually see in a Kubernetes cluster?
Good question. Yeah, so we as we said, we try to continue to add new integrations to our agent. So we have integrations, for example, for etcd or containerd, linkerd, fluentd. All these components are very common to see. We have integrations as well. So you can enable those integrations and start gathering specific metrics for those components. Aside from that, we also support the open metrics standard. So if you have any other component that emits Prometheus metrics, we can also send those to Datadog.
Okay, great. Here's another one for Gilson. How can I enable telemetry and logging, such as Prometheus, with containers running in Kubernetes?
Great question, and this goes along with Ara just point out. So Besides Oracle native services, users can use other open source tools like Elasticsearch, Fluentd, Kibana, Prometheus, Grafana. They're all available today for customers to use with OKE. So these open source solutions are most widely used with Kubernetes in general, and they're full support with OKE as well.
Okay. And then how can I manage state in Kubernetes orchestrated containers, deploying and managing storage in proximity to a Kubernetes cluster?
Great question. Yeah, and we spoke a little bit about that when we talk about the stateful and stateless apps. Basically, customers can use either block storage or our file storage service and access as a service. They can all be used for OKE, for persistent storage. So these services, they can be in the same region as OKE cluster, and the communication can also be restricted inside the region, so to not make it available to the public internet, for example.
Okay, and we'll take one more here. What monitoring tools are supported to monitor multiple OKE clusters?
Good question. So we spoke a little bit. Again, we have our own telemetry monitoring native service, but customers can also use Prometheus and Grafana to manage and monitor multiple clusters. Those are very common monitoring tools that I see our Kubernetes users using nowadays.
Okay, a lot of good questions. Okay, that's great. Thank you. Okay, thank you everyone for attending our webcast today. Please feel free to access the additional links that we have for Datadog in the resource list, as well as the slide deck. And also you can sign up for another live event or access one of our other on-demand webcasts. Again, this presentation will be made available on demand using the same link that you used to access the live event. When this webcast ends, you will be presented with a survey. Please tell us what you think so that we can make these webcasts more useful. We hope you have a great day.